Hello everybody. Today we're going to have joint probability distribution. This still addresses the course outcome computing the probability distribution of a random variable for both discrete and continuous data. The intended learning outcomes include using the joint probability functions and joint probability density functions to calculate probabilities. Calculate marginal and conditional probability distribution from joint probability distributions, and interpret and calculate covariances and correlations between random variables. Joint probability mass function. The joint probability mass function of a discrete random variable x and y, denoted by f of xy, satisfies f sub xy of f of xy greater than or equal to 0. So this still satisfies our previous discussion about probability mass function, that all probability mass functions should have greater than or equal to 0, should always be positive. The summation of f of xy with x and y as the random variable should be equal to 1 for all possible values of x and y. And to solve for the probability, you just plug in x is equal to x and y is equal to y from the probability mass function. Sometimes referred to as the bivariate probability distribution or bivariate distribution of the random variables, the probability of x is equal to x and y equal to y is usually written as p of x equal to x and y equal to y. And the individual probability distribution of the random variable. The marginal probability mass function of x alone and y alone are, for marginal distribution of x, it would be the summation of f of xy for all possible values of y, and the marginal distribution of y is equal to the summation of f of xy for all x's. Let us consider this example. The response time is the speed of page downloads and is critical for mobile website. As the response time increases, customers become more frustrated and potentially abandon the site for a competitive one. Let X denote the number of bars of service and Y denote the response time to the nearest second for a particular user site. By specifying the probability of each of the points in 5.1, we specify the joint probability distribution of X and Y. Similar to an individual random variable, we define the range of the random variables x and y to be the set of points x, y in two-dimensional space for which the probability of x is equal to x and y is equal to y is positive. So these are the signal strength, 1 bar, 2 bars, and 3 bars. And the response time rounded off to the nearest second would be 4 seconds, 3 seconds, 2, and 1 second. So these are the corresponding probabilities. Take note of this table because we might be using this on the succeeding examples. So how to evaluate this? For example, we want to get f of 2, 1. So x is 2, y is 1. So f of 2, 1 is 0.02. So that's the probability of x equals 2 and y equals 1. For example, we want to get the probability that x is equal to 3 and y is equal to 4. So that is f of 3, 4. So when x is 3 and y is 4, it would be 0.05. The marginal distributions. The joint probability distribution of x and y can be used to find the marginal probability distribution of x. For example, what we're going to do here is to add all the possible values of f of x for all values of y. So we consider y is 1, y is 2, y is 3, and y is 4 when x is equal to 3. So this is the marginal distribution for x. So adding those values, it would be 0.55. So this comes from the column that x is equal to 3. The marginal probability distribution of x is found by summing the probabilities in each column, whereas the marginal distribution of y is found by summing the probabilities in each row. So, for example, show that the column and row totals of table 3-1 gives the marginal distribution of x alone and y alone. So we have here 3 over 28. This is 6 over 28 and 1 over 28. So 3 plus 6 is 9 plus 1 is 10. So 10 over 28 or equal to 5 over 14. This is 9 over 28 and 6 over 28. So 9 plus 6 is 15 over 28 and then 3 over 28. So we can say that your marginal distribution fx, your x will be 0, 1, and 2, and f sub x would be 5 over 14, 15 over 28, and 3 over 28. For the row totals, so 3 plus 9 is 12, 12 plus 3 is 15 over 28. 3 plus 3 is 6, so this is 6 over 14 equal to 3 over 7, and then 1 over 28. So for y, the possible values of y are 0, 1, and 2. So f sub y of y would be 15 over 28, 3 over 7, and 1 over 28. Another problem. Suppose that x and y have the following joint probability distribution. Find the marginal distribution of x and the marginal distribution of y. So if we're going to add this vertically, so we have 0.1 plus 0.2 is 0.3 plus 0.1 is 0.4. 0.15 plus 0.3 is 0.45 plus 0.15 is 0.6. Horizontally, 0.25, 0.5, and 0.25. So we can have your x and f sub x. The possible values of x are 2 and 4. So it would be 0.4 and 0.6. Observe that the total is 1. For y and f sub y, the possible values are 1, 3, and 5. So this would give us a total of 0.25, 0.5, and 0.25 respectively. And the total of that is also 1. Two refills for a ballpoint pen are selected at random from a box that contains 3 blue refills, 2 red refills, and 3 green refills. If x is the number of blue refills and y is the number of red refills selected, find the joint probability of f of xy and find the region such that x plus y is less than or equal to 1. So we have 3 blue refills. And x is the number of blue refills. We also have 2 red refills, and y is the random variable for the red refills. We have the green refills, 3, and let us have z to be the number of refills. We're going to select 2 from all of this. So 3 plus 2. So we have 3 plus 2 plus 3 is a total of 8. And we're going to select 2. So the probability is equal to an f of xy, which is equal to 3 combination x times 2 combination y times z, 3 combination z. But we know that the maximum is 2. So what we're going to do is to have x plus y plus z is equal to 2. So z must be equal to 2 minus x minus y. So that would be 3 combination 2 minus x minus y all over 8 combination 2. So this is our joint probability distribution. You can evaluate this for x is equal to, we can have it 0, 1, 2. For y, it can be 0, 1, 2. And take note that z should be greater than or equal to 0, and z is equal to 2 minus x minus y. So this would be the restriction. For the next one, we're going to have the probability such that x plus y is less than or equal to 1. So we can have x is equal to 0, y is equal to 0. We can have x is equal to 0, y is equal to 1. We can have x is equal to 1 and y is equal to 0. So we can have this one as P1, this is P2, and this is P3. We plug it in here and then add this probability. So it's up to you to simplify the result. These are the references used in creating this video.